Hello, everyone, and thank you for attending today's webinar, Unleashing Generative AI's a Next Wave at the Edge, sponsored by Ambarella. Before we begin, I want to cover a couple of housekeeping items. On the left-hand side of your screen is the Q&A window. If you have any questions during the webcast, you can type your question into the Q&A window and submit them to our speakers. All our questions will be saved, so if we don't get to you at the end, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the question mark widget, and here you can find answers to common questions there. A copy of today's slide deck and other resources are available for download in the sheet of paper resource list at the bottom, including a white paper from Omdia and Ambarella on the topic that we're talking about today. Towards the end of today's presentation, please do complete the survey on your screen. It will only take 1 minute, and it's very helpful feedback for us. And finally, an on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. Now, we have two great speakers who are joining us today on the presentation. We have Amit Badlani, who is Director of Product for AI and Machine Learning at Ambarella. And we have Alexander Harrowell, who is Principal Analyst for Advanced Computing for AI at Omdia. Amit, Alex, thank you both for joining us today.
Well,
now, generative AI isn't anything new to people on today's call, or indeed at a wider scale. I mean, in the last 12 months, we've seen everyone from enterprises, vendors, consumers, and no doubt even friends and family form an opinion on ChatGPT and beyond. But what's the view behind the headline? What's really the story? And that's the perspective that we're going to get on the market from Alex, who's going to give us a few minutes from the Omdia analyst viewpoint. So over to you, Alex.
Thank you, David. Now I'm going to advance this, and can we just check that we can see the slides, by the way, if anyone can confirm that? Oh well, the first thing I'd like to talk about today is about the huge changes in the AI scene we saw during 2023, starting about this time last year. Now, this all began when the weights for Llama, the now celebrated model developed by Meta, were leaked back last February, and perhaps more importantly, what Meta did afterwards, which was to accept this and to release the entire family of Llama models as open source software. This meant dramatic changes in the AI in the world of AI generally. We saw an enormous outburst of creativity in the open source space, as we saw, an enormous number of large language models appeared over the past 12 months. And perhaps the most telling detail about this is if we were to go to Hugging Face, the hub of AI model distribution, we would find, when I looked on the 27th of March 2024, I found there were 83,532 models released under the Apache license, and another 26,000 or so under the MIT public license. I mean, this is gigantic. This is a gigantic degree this is an enormous amount of innovation. And what's perhaps even more impressive was that these models are very often rivaling or beating the very biggest projects launched by companies such as OpenAI, Anthropic, or indeed the hyperscalers. So, for example, OpenChat 7b, which is a 7 billion parameter model, matched or beat ChatGPT on 6 out of 8 tasks, despite the fact it's only 4% of its size. Now, and perhaps even more interestingly, we had fundamental discoveries in AI came out of this. So things like QLoRa. In the QLoRa paper, if you haven't read it, they demonstrated fine-tuning of a Llama-based model, which is Guanaco 65B, with 50,000 tokens of new data in 8 hours on a single large GPU, or perhaps in the space of a day on a desktop system with an enthusiast-grade GPU. So we're obviously not where we were at the beginning of last year, when it was assumed that AI development would always be the domain of huge companies, governments, perhaps the top end of academia. Something that could happen on a PC. In fact, what's happened is that development was radically democratized. Things have changed. Now, if we look at this chart, the graphic here shows a family, a sort of inverse family tree of models spreading out from llama originally. And I think the point I'd like to really strongly emphasize here is that much of the development cycle can now happen on single GPU servers or single server GPUs, or perhaps even on local PCs. And if we look back to the original PC concept and the transformation that the IT industry went through in the 1980s and 1990s, from mainframe systems and server systems to ones running on local PCs, we can see that was absolutely revolutionary at the time. And I think what we're seeing really is that as a field, as an industry, we're running a lot more experiments in parallel and consequently getting faster at innovation. And a lot of this has affected, first of all, the way we actually go about developing models, not just the models themselves. We have things like QLoRa, we've had direct preference optimization, we've had model merging, all of which are techniques which which help develop models, or at least refine them more easily. And also things like the GGRF file formats for deployment. So all of them make it a lot easier to start off with something with a pre-trained base model, create a derivative for some specific application of yours, and then deploy it for inference. Now, that has, in its turn, changed the size and shape of the problem. In 2022, there was a much-read AI research paper called "Machine Learning Model Sizes and the Parameter Gap," which took note of the enormous surge in model size that we had seen in the last few years. The one that took us from the era of things like Dreaming Deeply to GPT-3, and further noticed that this growth actually appeared to be slowing down since the rise of the very large scale models. And interestingly, there was a gap, which you can see on the chart, which I've marked on the chart here, in the range of sort of maybe 20 to 70 billion parameters, where there were surprisingly few projects that landed in there. Now, since the explosion of open source AI last year, literally hundreds of models have appeared at the bottom end of that gap, so actually more than 5 to 50 billion parameter range. Small language, people talk about small large language models, or SLMs. Now, and if we think of some of the two biggest hits we've seen in the last 12 months, Mistral 7 billion, 7B is obviously 7 billion, or Mixtral both fall into this range. And the huge advantage of this is that these models will both can be developed much more cheaply on cheaper hardware. They also run on much cheaper hardware. So they're going to deploy outside the data center onto local PCs, onto mobile devices, onto embedded systems. So anything that can find 8 gigabytes of available RAM is now a potential platform for a language model. And this goes doubly so if it has a unified memory architecture. And this is something which I think the vendors who've worked on that will find a substantial advantage. Thinking slightly differently, thinking in terms of the use cases, we're beginning to see a transition from out at the edge, from basic consumer computer vision models to these small language models. So if we think of something like Clip, for example, which is a joint text and image model, this is increasingly being deployed out to cameras and to edge systems to provide the ability to do natural language prompts over the camera feed. And if we look at the table here, we're seeing, for example, in the smart city applications, we're seeing a move from things like YOLO version 3 or version 5, or ResNet, to something like Lava or Vision Transformer. And that's obviously a substantial increase in the demand for compute and for memory. We could also see this in terms of things like home security, and developer support, industrial robotics, and medical instruments. although this new breed of model is economic in terms of compute, if we look at it in relation to the data center and the cloud, if we go out to the edge with it, it's going to be a substantial increase in the demand for compute and memory, and especially memory bandwidth, which is, of course, the binding constraint for transformer models. Anyway, and when we look at the market for the hardware, we're seeing big changes afoot. Now, the chart here is taken from our AI processors for the edge forecast, and one of the things we've noticed in the mobile space is that everything is moving upwards along in the performance range. So the products which appeared in 2018 to 2019, which had like an NPU with like perhaps 1 teraops per second, are being replaced by ones approaching 5 teraops per second, whilst ones that had 10 to 20 teraops, like the Apple A15, are being replaced by ones with 30 plus, like the Apple A17. And Qualcomm, for example, is set an objective of running models with 10 billion parameters on premium tier smartphones. Ambarella, for its part, our hosts, have demonstrated the 13 billion parameter Lava running on its N1 SoC. And I think, generally speaking, I think the mobile vendors are converging on running a 7 billion parameter locally as their benchmark. Now, and just to put this in context, the edge is the biggest AI semiconductor segment today. I don't think many people really grasp this. It incorporates the smartphone market, which is the biggest semiconductor market, plus the PC business. That said, you'd be surprised how many smartphones already have AI acceleration. Growth is inevitably slowing down because that market's now rather full. We expect the surge of GPU investment to cause data centers to overtake edge in 2024. We brought this forward in 2026 this year, but we also expect the surge of investment in the data center to saturate that market quite quickly, and as a result, the edge will catch up again later in the decade. Now, and as the pandemic era spike of PC sales comes up for replacement, we expect to see AI silicon head into the PC market in quantity. Just to give some idea of what we're doing with these things, in our generative AI software market forecast, we reviewed about 250 distinct use cases, and we found that the biggest category and the biggest growth driver remains visual analytics. Increasingly, we're using cameras as a sensor for everything, and I think this is going to pull through demand for those models we were just talking about a little earlier. Some of this is taking over from other AI models, as we can see on this chart. But there's also, if you look at the pink line, there's also a significant amount of incremental demand coming from this. And with that, I'm going to hand you over to Amit.
Well, thank you so much. Good morning, everyone. And again, thank you so much for the opportunity. We will, of course, see a lot more advancements. As we saw last week, Llama 3 was launched. Alex talked about QLoRa and fine-tuning, getting some of these models to the edge. And Ambarella has been instrumental since its launch in 2004 to actually push innovation, both in computer vision and AI, onto the edge, especially in visual analytics, which is one of the biggest applications we saw generative AI will boost. So, I probably want to check once if the slides are still visible. I think some of the audience members said that it was stuck. Hopefully, everything is running smoothly. This slide talks about the evolution of Ambarella since its launch in 2004. We first saw the era of human viewing, where we were trying to make cameras on the endpoint smarter. And so the company focused mostly on the video processors. And in the last decade, our focus has been to get computer vision, especially perception in the form of CNN networks for image detection on top of the edge devices. And that's, of course, benefiting a lot of the endpoint use cases like automotive with ADAS. We also see huge improvements in industrial automation, as well as some of the use cases in smart cities, home security. And as we see perception sort of become the norm now, we've been seeing this transformer wave that has hit us in 2017. And Ambarella as a company has been instrumental in bringing all of the latest innovations on the transformer technology side onto the edge with its chipsets as well as the software stack. And the latest software stack that supports this is the third generation of the CV flow. The processors are going to be 5 nanometer technology based, and they're still addressing the same market, but instead of just doing perception, now we are actually able to handle multimodality, where we take in text, audio, video inputs, and transform it into some insightful information, as we'll see in the future videos. So with that, basically just want to go back and summarize on what Alex talked about. Visual analytics is still the number one Gen AI opportunity with all of the survey that was done, thanks to Omdia. And some of the industry verticals we see that will benefit from this is clearly industrial automation, with a lot of robot arms as well as warehouse robots being deployed. We'll also see innovation on the smart city side, where the searches become more contextual. Now, instead of just having a YOLO model detect objects and guide you, it's actually going to be much more insightful when you can contextually add text queries and searches. So at the endpoint, you can actually keep your video feeds private on an on-prem or on-device, like on the camera, and you can still do contextual queries on the endpoint. So that's an application that's emerging quite a bit in home security, as well as security in general for other enterprise use cases. And then it just goes beyond security and in terms of like giving tailored insights for certain scenarios where you can have cameras monitoring a particular process flow. We also see that in medical devices. Data here needs to be private, and it cannot quite leave the endpoint or the edge server. So here's where we'll see a lot of innovation as well, where medical devices start getting much more smarter. And of course, our beloved robots are now coming from industries to consumers as well very soon. In terms of the compound annual growth opportunity, I think robotics is beating AI and Gen AI even. So we'll see a lot of robotics adoption with humanoid robots and other consumer robots coming. Of course, we see tremendous deployment in the warehouse space and the last mile delivery. So those will continue to grow. And we see that visual analytics will keep using generative AI for those text plus video multimodal AI use cases. And Ambarella is going to basically power those going forward with our chipsets, which we'll talk about a little bit in detail. So again, I think from a model perspective, what's happening is there's a clear shift in paradigm from larger being better to smaller models that are more efficient and purpose-built for a particular use case. We certainly see edge use cases actually being benefited from that as models become much more nimble and efficient. You can now have more memory and power efficiency, which is what was missing with the 2017 wave of transformers as the models kept getting bigger and bigger. Of course, larger models brought in much more accuracy, but we are seeing concepts like fine-tuning and also techniques like QLoRa, which Alex mentioned earlier, sort of help out reduce the size and footprint of these models, and basically like reducing the total cost of ownership at the end of the day, because you're bringing in those memory and power efficiencies at the edge point. So again, I think from the cloud data centers, if you think of that as the top buckets where most of the CPU, GPU, and FPGA applications lie, you're seeing a lot of those applications now move to the edge, and edge becoming more prevalent and getting benefits of multimodal AI. This refers to both IoT endpoints, which includes cameras, robots. We talked about other use cases like smart cities and autonomous driving, and then network edge as well, which is the edge compute, the edge server on premise, so that the data doesn't really leave the cloud; it's still private. We spoke about those use cases also, and this is where most of the high volume use cases will lie. And Ambarella chips are actually going to power some of those endpoint applications and actually most of those edge servers going forward as well. We have a few exciting products that I would like to talk about. But basically, as we see the rise of smaller, more efficient models, just wanted to summarize first on how the model landscape looks like. So we have large models, which are greater than 50 billion parameter models. They are still going strong on the cloud for B2C use cases, serving the consumers. The missing middle is something that Alex spoke about, and Omdia have referred in the white paper as well. These are 3 to 50 billion parameter range. There's not a lot of models in that 3 to 20 or like 20 to 50 billion parameter range, which have now seen a huge growth. So both 3 to 20 billion parameter range has seen tremendous growth with Llama and other models like Mixtral. And we also see a huge boost in the range, which Alex talked about, which is 20 to 50 billion parameters. So we definitely believe that those are the models that are more coming to the edge server use case. And then, of course, there's the smaller language models, which are also multimodal, but they're very, very purpose-built. So, for example, an industry vertical like retail might have its own set of models. Smart cities might have their own. And so this is just basically classifying all of the models and the landscape in 3 broad categories. And how Ambarella comes in is that with our N1 SoC, which we just launched earlier this year at CES, we're going to target both the missing middle and larger models. And the CV7 family targets the smaller, more nimble models at the endpoint, which are directly running on the camera. And these are some examples are Clip, as well as the Phi 2, which is the 2.7 billion parameter model that was recently released for Edge specifically. And in terms of the missing middle, we see Lava, Code Llama, and a lot of Gamma models as well. I think Llama 3 was also launched with that purpose. And we saw Llama 3 8 billion actually outperform Llama 2 70B, which used to be a large model. It's shown as a large model here. So again, tremendous progress that we see, and models are getting more and more efficient. We'll just I'll share my computer screen actually to show you guys a couple of applications. One of them is vision analytics. So we'll basically see how do multimodal models work. I'm starting to share my screen. Hope everyone can see it. So we'll just start playing this video and talk through it. Basically, what you see is a camera that is attached to a edge server sort of an application. Everything happens on-prem locally. So think of this as a hub for multiple inputs from text, audio, all the way to video. This is running multimodal language model, which is Lava in this case. And we can support up to 34 billion parameter Lava models on this device. And you can see on the left-hand side, we're basically chatting almost with the application. So you can think of use cases where you have 16 camera feeds coming in, and typically it takes a long time for archival footage or live footage. But here you're able to pull in an archive or a frame from a live video, and you're able to contextually search and ask questions. It's basically an entire internet that's trained on your small edge device. You can have multiple streams flow into that edge device, and it acts like a hub where you can contextually search through videos. And so it makes it a little more engaging versus the previous workflows before generative AI have been very, very manual, where you have to go scrub through the videos. So I think this is, again, going to be a very exciting, one of the exciting features that we'll see soon with multicam AI hubs and even like edge servers that are processing multiple frames. And this is, again, like for context, everything was running sub 50 watt. So it's not just important to have higher parameter models with higher accuracy run, it's also important to note the perf per watt, which is increasingly going to become more and more important. And Ambarella brings that at the edge. The next slide will basically, I wanted to go back to the categories we spoke about and talk about the Ambarella SoC generations that target this. So as we saw before, the N1 series is really targeting the missing middle. The models we saw, one of the demos was actually the 13 billion Lava model. Again, we can run up to 34 billion parameter models. That includes Llama, Lava, Gamma, and some of the other smaller models like Phi 2 and Clip on the N1 series. Again, this is very fine-tuned models. It's actually using QLoRa and other fine-tuning techniques. So the power utilization is actually very, very low, and it's industry-leading per watt performance. The second category, of course, is the Series 7, which is for smaller models. So you think robotics, where you have edge modules and cameras on top of a robot, and you sometimes need more processing to happen on the endpoint camera. Same with autonomous driving, where you want the cameras to be slightly more intelligent, to be able to parse details so that there's less loading on the central domain controller. And this is going to be an essentially big use case for models like 500 million parameter to 3 billion parameter. We've seen Clip used quite effectively, both in robotics as well as otherwise in smart cities. So we definitely see intelligent, more smarter cameras come to your robots, as well as other smart city use cases, including security. These again include Phi 2 and Clip that we spoke about. They're mostly sub 1 billion parameter models. Some for higher accuracy and more modalities do go up to 3 billion, and Series 7 series supports that. Next is a demo actually that I want to show on multiple camera streams. We saw how Lava was able to intelligently parse one stream. We can do that for multiple streams, and here we're using a smaller model on a AI hub. So let me go ahead and share my screen. So hopefully people can see a multicam view. And you see 16 camera streams. These are live camera streams from different angles going into a control room. And in the control room, you basically see a confidence view where you can search for a tiger being detected. And then you see the channel 8 here does have a tiger and highest confidence. So what the model is doing is it's detecting a probability of that particular phrase. So now we're going to detect an airplane. We saw the airplane in the previous video. We saw it should be channel 3, and that's what it depicts. It basically depicts a highest probability of whatever you're asking it for. So in the airplane use case, as you can see, you see airplane on the 3rd channel, and then here on channel 3, when you search for it, you see the highest probability. Others all have a very low probability, so it's probably not detecting it. And this is basically Clip on action. It's a sub 1 billion parameter model, but again, this is all running on 16 streams real time. So it basically shows you one of the use cases where you can run 16 to even like 24 camera streams. We actually on N1 will support up to 24 high-res 1080p 30 video streams, and you can intelligently go about analyzing those. So again, moving through the rest of the flow quickly, we see a lot of generative AI applications. Alex talked about this, just this table summarizing it, where we see smart city as one of the top use cases. We kind of showed 2 demos on that. Home security and industrial robots are still going to use MobileNet and YOLO and still would need some other augmentation. And so the future models will actually be Lava or like other versions of vision transformers that basically will start helping out with imitation learning in collaborative robots. And in home security, we actually see natural language kind of contextual searches that we showed in the demo before. So Code Llama is also some of the one of the biggest use cases in a developer kit environment, where you want to convert your code from one particular language to the other. And there are plenty of use cases where you want to just quickly get started. And you're seeing a YouTube video which you want to convert into a text code very quickly. So those are some of the computer vision use cases we've seen our partners use, and developer kits that come today with the Code Llama pre-installed are actually able to use text and code to increase productivity for some of these edge applications that developers are developing. Again, I think to make this possible, we have 2 kits that will be shipping. One is a Cooper Max, which is based on the N1 that can support up to 34 billion parameter foundation models. And the other is Cooper Mini, which actually supports up to 3 billion parameter foundation models. And this is more for a smaller sub 10 watt footprint, that you want to go for. So both kits are available, they're shipping today, and you can get yours to prototype some of these edge vision applications. With that, I will let the audience and David sort of take the questions.
Thank you, Amit, and thank you, Alex, for the presentation. So before we get to kind of throwing a few questions at our 2 presenters, actually we have a question for you, our audience, to start. And that is, what is your biggest single consideration in deploying generative AI at the edge? Is that application and use case? Is that computing power? Is that security, reliability, cost, scalability, or size? So if you hit your answers on there, and then I'd be interested to hear in a moment how those results match up to, or indeed surprise our experts on the call. Whilst you guys are clicking on the results on the question there, just as a quick reminder, we will be doing a live Q&A just at the end of this session today. So don't forget to submit your questions there. And also don't forget to look at the resources at the bottom. You should be able to download the white paper, where I think both Amit and Alex have referenced a few of the interesting things from that. But you should be able to download and see the results of that as well. We'll give a few more seconds just for people to click on their answers, and then let's see what people are saying. So let's have a look. I think, well, certainly from my perspective, predictably, it's use case, it's application. It's always the first place to start. It's the most important place to start, is understanding what benefit it's going to bring before we move this to the edge. But interested to, like I said, hear how that compares to our experts' view as well. So let's ask Amit, actually, Alex, let's ask you first. This is not the first time we've tried to move things towards the edge. What parallels do you see in the transition from, say, mainframe model to PC model, with the transition of generative AI models towards the edge?
Well, I think one of the biggest changes we'll see from this is actually on the inference side in terms of unit economics. One of the nice things about the PC model, from a business point of view, was that when you sell software on it, the unit economics are fantastic, because there's basically, because the cost of actually of copying and distributing code is minimal. and the users on their machines provide the infrastructure to run it. So the margins for software packaged software companies could be absolutely fascinating. And I think that those kind of fantastic unit economics might make a bit of a comeback if we're deploying applications out to PCs especially, because whereas, I mean, by comparison, if you're doing inference in the cloud, you're invariably going to be giving up a substantial amount of the marginal sale to your cloud provider, and that's always going to also be a difficult relationship to manage. On the other hand, I mean, we'll see some changes in terms of development, but we'll probably always need substantial compute resources to do fundamental models, even if we are doing local fine tuning. But I do think one thing we will see is I do think it will help developers and startups a hell of a lot, just on the basis of unit economics.
Thanks, Alex. And Amit, for you talked in the presentation about visual analytics in particular. So what is driving that predominant focus on using Gen AI for visual analytics going forward?
Yeah, I think we see a lot more adoption there because use cases have predominantly, even if you see the AlexNet moment in 2012, it's been about vision and images. So whenever we've sort of gotten intelligent algorithms, whether it was computer vision back in the early 2000s, all the way to machine learning in 2010s, and now transformer architectures, we've seen that go to vision first and really transform it in the way we look at things. So from cameras, being able to just, you're manually detecting scenes to automatically sort of have bounding boxes, detect objects, have intelligence based on that. And with the transformer architectures, we definitely see with these language models making natural language understanding better. That's really how we should be interacting with each other, just like you and I are talking right now. English is going to be the most used programming language, and it's also going to be the mode where we communicate with our robots or with the cameras in the case of smart cities. So that's really where I see visual analytics getting a boost. A, natural language understanding, where you can talk to your cameras now more effectively, and B, you're able to alert folks by sending them relevant text messages, or really a smart camera actually sending messages as opposed to manually going and scrubbing through videos. So definitely that's one of the major areas we see a boost, which is confirmed by the study Omdia did.
So if that's the kind of the type of model and some of the challenges moving forwards, let's talk about verticals. We said applications came out as number one. So let's think about which applications or verticals that this is going to get the biggest deployment. We have our second audience poll question as well. So the second question is, where would you be most likely to deploy generative AI at the edge by verticals? So again, if you start hitting your answers now, the options are smart cities, industrial and manufacturing, consumer, retail, healthcare, automotive, business services, or telecommunications. So if you start hitting your answers now, I know we've mentioned one or two of these already through the presentations, but again,
I was going to say, I hope we didn't bias the audience with smart cities. We definitely showed you smart city videos today, but we definitely see use cases other than smart cities also get a boost. So it would be interesting to see what others feel.
Absolutely. And by the way, I know there's a few questions around where to see the white paper and the on-demand. Just to reassure people that if you can't see it now, we will be able to send that out afterwards. There will be an email that comes through in around kind of 1 day's time where the on-demand version will be available. I'm sure we'll be able to make sure the white paper is available there at the same time as well. All right, we've got a few answers in here. So let's see, the moment of truth, have we biased things with smart cities? I guess we have a little bit, but also industrial and manufacturing, which makes sense. You talked about automation, for example, earlier. So Alex, let me come to you. We talked about smart cities, but from your perspective, do your expectations match what we're seeing here? What are the other verticals where you think you'll see the greatest benefit of this transition towards the more specific models at the edge?
Well, I think really, I'm looking to the other category, towards the sheer range of miscellaneous possibilities. This sounds like a bit of a cop out, perhaps, but the real benefit from working with large language models and these things is the ability to prompt them in natural language or near to natural language, and therefore to develop, or would we call them applications, but skills applications, what you want to call them, very easily and very quickly, and that the users will be able to work with them much more easily. I think in robotics, for example, there's a great deal of excitement about so-called cobots, robots which are designed to cooperate, to work around human beings rather than being machine tools lashed to the ground. And I think being able to change things quickly in a production setup like that would be very valuable.
And Amit, for you again, beyond smart cities, maybe what are the biggest applications and verticals that you see?
Yeah, I think the biggest we've seen so far, besides automotive and smart cities, is just industrial automation and also healthcare. I definitely see healthcare is not as high on the survey list and people's minds, but it's changing quite rapidly with most of our world being tokenized. So will proteins, genomes, and those sequences. And I think that's the next frontier where that helps us with much more high intelligence, where we're augmenting doctor flows with some of these sensors that can get us real-time data, and then we have natural language understanding inbuilt into it through these language models. So I definitely see a boost there.
Makes sense. And so we've talked about verticals, we've talked about type of model, but I think another key question, and certainly having just been at Embedded World a couple of weeks ago, it was a topic that came up a few times, which was then about the power required at the edge. So as Gen AI use cases grow, and so does the power required for training and inference, what can be done to mitigate what could become actually a real environmental issue? For example, do you see a push in the ecosystem to create specific models dedicated to specific verticals to kind of improve accuracy whilst reducing compute requirements, for example? Amit, what are your feelings on the kind of power and environmental side of this equation?
Yeah, I think energy definitely becomes an important point. It continues to be in discussions. Every company, from Meta developing these models, which are open source, and OpenAI sort of unleashing this wave upon us, they're constantly thinking about model architectures. That's where we see a lot of smaller, more fine-tuned and efficient architecture come to the edge. But from a hardware perspective, I think on the chip side, you also see a lot more innovation now happening where energy efficiency, power utilization, DRAM utilization being looked at. And that's something that's important because essentially for inferencing use cases, which are happening quite a lot more, even on the server side, on the cloud, you're basically seeing not just the capex of having the GPUs installed to run these language models, but also the operating expenses of the sheer amount of electricity used. And again, it's a dollar amount as well as environmental, sustainability that we want to go root for. We've seen, efficiency being driven both from the model side, top down, and from the chip side,
And Alex, anything to add from your side? I know that the cost of inference, for example, is a big topic of conversation that our clients are asking us at Omdia at the moment.
Yeah, well, I'm really excited by the emerging state space models. This is a category that basically replaces the attention window and the transform models with an embedding of what it's done so far. And so it holds state rather than doing starting at the beginning and add it with each additional token. This is interesting because it gets rid of the quadratic of the problem that memory usage in transformer scales quadratically, and therefore reduces some of the huge demand for memory, and especially accelerated memory. Most of the power draw on these things comes from just keeping the either system DRAM or accelerated VRAM alive. So if we can move beyond that, that would help a hell of a lot in itself. And if you're looking for an example of one of these, the first one the ones to look at are striped hyena and mamba.
Okay. And one final question then, and then we will go to audience Q&A in a moment. I see a few questions in, but to kind of wrap us up on the panel discussion, Amit, what advice would you therefore give to enterprises and developers that are trying to determine their adoption path for generative AI at the edge, either edge endpoints or on-premise applications?
Yeah, I think one of the things that I would lead with is your edge endpoints can be much more smarter than you think. And so offloading some of that to keep the data private is, of course, one of the top considerations. So definitely think about privacy once you deploy some of these language models. The second most important point is going to be energy sustainability. I think whenever you talk about like on-prem and endpoint, it's important to sort of offload what use cases you're going to be running in the on-prem scenario or cloud scenario versus the endpoint, now that the endpoints are getting much more smarter. And so those two would be important. And then lastly, guardrails. As with any generative AI or machine learning model, these are just approximations. They're not going to be as accurate as a human if you don't have techniques like RAG, or which is retrieval augmented generation, inbuilt. So think more in terms of how can you have those necessary guardrails such that you can still automate the flow with higher accuracy.
And finally, Alex, same question. What's your kind of 1 minute hot take on where should enterprises or developers focus?
First of all, I would make sure you design things so you can switch out your AI models, as that's where the change is happening the fastest. So you need to decouple everything else from it. This is generally good practice to break up systems like this for software development purposes, but this goes double or triple for AI. You definitely need to think about the silicon when you think about your unit economics, because if it's coming from the cloud, the bills to whichever provider will be a huge part of your business. If you're providing the hardware, if you're buying the hardware, that's always going to be a big driver of your bill of materials. So you need to stack these, to think across the whole stack. And I'd especially keep an intense focus on how the technology is changing, because at the moment everything is seems to be about GPUs and big transformers, but it's not necessarily going to stay that way.
Makes sense. Well, thank you both for the presentation. Let's move to audience Q&A. I already see a few questions in here. I'm going to start. Amit, this is a very specific question for you, which says, what's unique about Ambarella's ability to innovate in edge AI that allows you to be much more efficient or effective than AI silicon competitors with a far larger R&D budget? Brackets bonus points for any NVIDIA career reflections.
That's very interesting. Thank you for the question. I definitely think that cloud is going to still continue to be really transformative, whether it's training these models on scale or deploying them, B2C use cases, as well as some of the enterprise use cases as well with private cloud. So I just want to say that that's not going anywhere. The innovations that we see happen on the edge, which we see a large adoption of AI PCs, the whole wave coming. We also see cameras becoming more smarter. That is more for the edge endpoints to become more smarter so that they can offload and you can handle data privacy better. Right now, the only way was to actually send all of these prompts and your computer data or your vision data from your camera endpoints all the way to the cloud to make decisions. Now you don't have to do that anymore. You have that sort of flexibility. As far as Ambarella's key capabilities go, it's always been in vision markets and very focused on endpoint and power efficiency. So it's basically going to be working in conjunction with other processors, whether it's cloud or on-prem. So the key I see is power efficiency and memory efficiency, which is two most important things you see when you talk about endpoint applications like cameras, from edge cameras all the way to different sorts of stereo cameras and other modules which we see in robots like for stereo vision and depth sensing. So Ambarella will continue to innovate there and get more and more DRAM power efficiency, whereas you'll still see the cloud applications increase. So this to me is more on making edge more smarter. That way you can handle the privacy and you have more levers now to pull in terms of what sort of intelligence you want to deploy at the endpoint versus on-prem and cloud. Earlier, the flexibility was very low, where you had to actually, for any kind of natural language understanding, you had to go to the cloud, which of course has privacy considerations and OpEx considerations, BOM considerations, which Alex talked about.
Thank you. And by the way, just as a note that we will get through as many of these audience Q&A questions as we can, but they are saved. So if your question doesn't get answered now, I'm sure we'll be able to. I'll volunteer Amit and Alex to be able to follow up with you afterwards and share some thoughts. So if I move to another question here, it says, with models being trained by large companies, Llama, etc., how could smaller companies differentiate themselves to be competitive? Alex, what are your thoughts on that? And then Amit, I'll ask you the same question.
Well, I think the first thing to say is that it's never been easier to fine-tune, merge, or otherwise adapt one of the open source models for your own unique use case. And I think learning to wield those tools like a katana blade is the way forward. Is the way forward here. I mean, I'd even point out that a lot of new developments have come from sort of penniless groups of open source enthusiasts. I really think although Llama itself originated at Meta, I really think this has become much less of a thing. I think one big barrier is actually data rather than computers just marshalling the data sets for these things. But on the other hand, if you do have interesting data resources or skills to curate the data sets, that's I think that's a rare and precious speciality. One of the main things about Stability AI's successes, although it has plenty of problems, but its successful models it's developed is that it did a very good job of curating the data set going into it.
And Amit, yeah, what about your take? So for particularly that, how do smaller companies differentiate themselves to be competitive?
Yeah, I mean, I second that. So the two ways I see, data is your moat, right? Alex sort of talked about that. So data is becoming more and more important. How you structure it is also extremely important. because with all of these like high parameter large models, we see a lot more data, which is not as useful. So there's this whole wave of like making the end data points much more efficient, training on the right data, right? So having focus on that is definitely going to be key, because data is the fuel fueling some of these models. The second thing to look in is also the efficiency and targeting industry verticals. So I think a lot more companies are going after AGI, which is great. They have great R&D budgets, all the way from like Meta, OpenAI, to even companies like Nvidia are very focused on developing models, bigger language models. I think that's going to continue to be the case in the future. And for smaller companies, the focus should be what industry vertical are you trying to target? Just as an example, like retail could have very different requirements, and there are two approaches to solving that. One is to really take a AGI or a really large model and fine tune it or ground it on your retail use cases. The second approach could be actually having retail specific data where a smaller company might have a moat. They might be working with partners, or they might themselves have access to a lot of good data on retail, and they could potentially develop a smaller model which is more purpose built on that particular application. So having specificity on industry verticals and using data as a moat, I think those are the two key things that can definitely help small companies as well.
Everything always comes back to data. So we have one time for one more question. And you were talking about kind of more specific applications there. So let's finish with a vertical question. So how will bringing Gen AI functionality to the edge help home security companies reduce total cost of ownership while adding these new capabilities? Amit, I'll let you provide the final answer.
Yeah, no, absolutely. So I think one thing that I talked about was that now that Edge becomes much more smarter with these language model capabilities, what we have provided is levers to the users where they want to run these language models and how much. So what that helps is when you talk about the operating expenses or the cost, right, of using a cloud service, and sending all of your prompts there, you pay per token. Yes, that token cost is coming down. It's a few cents, but just now, my answer, probably has 1,000 tokens already, right? And so, those bills stack up quite fast when you're trying to do this intelligence. And we see, companies pay, anywhere from like tens of thousands of dollars all the way up to millions of dollars in just, analyzing the tokens. And if that particular intelligence can actually, some of it can be on the endpoint, whether it's on a camera, which is where, Ambarella's most of the innovations lie, then you can sort of take that costs down rapidly, and you can basically reduce your not just capex, because some of those capabilities now come in a much smaller form factor on top of the camera, but you could essentially have a level where you only run the most important insights or queries on the cloud or on-prem, versus running everything on there. So that's the total cost of ownership piece, which is, of course, a lot of it is hardware expenses. Because if, let's say, you are an organization that wants to keep the data private, you'll likely invest in a private cloud or on-prem, which is again like hardware investment in some cases. But some of it can be software as well, which is oftentimes dynamic and recurring.
Thank you. And with that, I think we're right up against time. So that's everything we have time for. Thank you to everybody for participation, for submitting your questions. And of course, thanks to Amit and Alex for your time as well. Don't forget, you can download the white paper. We've refreshed that. You should definitely be able to see the white paper in the resources. And if not, then keep an eye out for that on-demand email in around a day's time, where you'll be able to watch back to the session and again be able to download the white paper from there. Please do take a few moments to fill out our short survey on screen in a moment. But most importantly, thank you for everybody's time for joining today, and have a great rest of your day.
Thank you so much, everyone.